Hello, everybody, and welcome to another edition of Biology in the Basement with your host, Mr. Andraco. Forgot my audience yesterday, and it felt very weird without it, so I brought the audience back this installment so that we can liven it up. Also, speaking of livening things up, ironically, I would like to give a shout out to an unsung hero of the Biology in the Basement, and that is Mr. Bonesy here. Mr. Bonesy has been a great boom guy, holding this mic and not saying a word, not trying to steal the show from Andraco here. And so, way to do your job. Let's give it up for Bonesy. Hey, I really like you out there. Also, if you'll notice, my instruments have been forming in the background. If I don't ramble on too much one of these times, or maybe I'll do a separate video showing you my instruments because I love them so much. But we've got other things to talk about. The purpose of this lab is to wrap up the excretory system. We're going to just talk about 4 excretory organs, 4 excretory products, and how they fit. As you can see, I've got an old warm-up style setup here for you guys to think about, and then we'll fill this baby out, and that will be it. And I'll give you the objectives, and you'll be on your way for this week. We're going to do a little pulse lab demonstration next week for you. We'll see how that goes. I haven't quite designed it yet. Hopefully you guys will play along too and show me your data. But we'll get to that later. We've got to get started. So here is your fact of the day. And that is, during World War II, England was worried about being invaded. So what they did was they removed all of their road signs. All the road signs on the streets were removed in case the Nazis made it to the United Kingdom and wanted to find their way around, and they would hope without the signs they would get lost. So pretty good thinking, pretty good planning ahead. So let us have a quick chat, and I'll give you your assignment, and you'll be on your way for the day. So we've been focusing on this side, the good stuff getting into the blood, your amino acids that you've digested from your proteins, right? Your oxygen you've breathed in, your glucose from either mono or polysaccharides, and of course the number one nutrient is water. But we've got to get the stuff that our cells use and turn into waste products out of the blood as well. Right? We want to keep cells happy, and things like CO2 and water and other waste products like uric acid will really throw off the homeostasis. It is toxic to the cells, and they must get out. Okay, we monitor the pH of our blood because, right, pH affects my favorite enzymes, right? So we've got to make sure we have a good pH. So we've got to get things like carbon dioxide and other acids out so that our cells are happy and working their best. So how do we do that? We've got 4 organs. 3 of them are here, right? The liver, as I mentioned yesterday, very important. The main one that we will discuss is the kidney, but we can't discount, as it shows here, CO2 leaving the lungs, as well as the largest organ of the body, yep, the skin, right? That is also an excretory organ. So those are your 4 excretory organs. The 4 excretory waste products can be things like uric acid, also known as urea, water, whether it's coming in or going out. It can be a nutrient and a waste product because it's used by cells. Too much water is actually bad. CO2 is a waste product we must get rid of, and mineral salts, byproduct of acid-base reactions. So I would be short-sighted if I didn't mention the other 3, but most biology texts and the Regents exam focuses on the kidney. And here are its 3 main jobs, right? Get the waste out, keep a good pH, and keep a good volume. Not too thick, not too thin. keeping your cells happy. And that's its little component of maintaining homeostasis. Hint, hint. This is like objective 22. Okay, so inside the kidney, there are millions of these little units called nephrons. Nephrons are the blood filtering units. Another cool word is there are two main types of nephrons: cortical nephrons, which are on the outside, and then the ones on the inside are called juxtamedullary nephrons. It's almost as cool as hemoglobin. Anyways, we've got some parts here that are responsible for the filtering of the blood, getting it out of there, but also we got to maintain that water content. And so we've even got a part that is responsible for that. So in the big picture, right, bad blood goes in, that's dirty. The dirty stuff, or what we call filtrate, leaves the kidneys and heads to the bladder where it forms urine. And then the good clean blood goes back on its way through the body. This also happens at the liver as well. Of course, the skin and the lungs also get rid of stuff. But this one's more important for general excretory products, and that is because this nephron, millions of them, are taking the filtrate out through a capillary that sits inside of what's called Bowman's capsule. And so all this filtrate leaves, and depending on our situation, whether we're dry or dehydrated or whatever, we will reconserve some water, reclaim it back into the blood to keep that proper blood volume. So those are the two steps. First, we filter in the glomerulus, then we reabsorb in the loop of Henle there, and then urine is formed. Okay, so we get the filtrate down into the bladder, and then it heads out the urethra. And we'll talk more about the urethra when we get to the reproductive system. But the ureters are the tubes that bring the liquid filtrate to the bladder. And you've got two sets of sphincters to allow you to remove that. So, here is your assignment before we get to that. Objectives 22 through 27, right? Those are the 6 of them that deal with the excretory system. And I think you'll be able to get through them very quickly. We could probably do them together. All right. Oh, yeah. In case you were playing at home, out of the 57 guys during the blood typing activity, 0 fell. But I've knocked over about 27 since that day. Okay, so what are the 4 excretory organs? Skin, lungs, liver, kidney. All right, so what organ is filtered from the body? Skin, lungs, liver, kidney. Now, what are the 4 excretory excretory products? Well, luckily, the kidney, the liver, and even the skin filter out all, 3 of the 4, and those are mineral salts, right? Water is what the most of your sweat is, but some uric acid, right, also leaves the body through your skin. The lungs are responsible for removing CO2 And anybody who plays a horn, specifically the French horn, knows this one is water. Every time you exhale, carrying that CO2 out of your blood is a water molecule. So CO2 and water are excreted from the lungs. The liver and the kidney are the same, where they deal with the mineral salts and the uric acid mostly. Those are their two big ones that they are responsible for getting rid of, because your urine is mostly made up of salts, potassium salts, and different ions, magnesium ions, as well as uric acid or urea, which is your nitrogen waste. But of course, you can't get this stuff out of the body without good old H2O. That's why it is an important nutrient and other just all-purpose helper, in that it helps to carry waste products from the body as well as get them into the body when we inhale and eat and things like that. So this would be the official table. I think this is objective number 26, and it also includes answers 24 and 25. Don't forget to do 22 up there. That one's there too. So very simple objectives. Here's all your answers. Hope you could bear with me on this choppy, bumpy ride here, but we got through everything. So good job. Be safe, and I hope that you guys are well. Remember, check school tool. Check school tool. Get your work in. Okay. This is Andraco signing off. We'll see you.